And we have the radius of the circle is 4. The radius of the circle in this case is not the size of the square. I'm going to quickly go through several different ways that you could have tackled the area of that square. Some of you might have extended this radius to get that we have a diameter of 8. So for me, actually, that's kind of the hardest way to see, but it's a great method. So now if you focus on this right triangle, and we know more than that it's a right triangle, we know that it's an isosceles right triangle because it's a square. And because it's a square, those are equal, which make both of these angles 45 degrees, which makes that yellow triangle 45, 45, 90. So we have our pattern of A radical 2. If you remembered that, you could use that to get the missing side of the square. If you didn't remember that, if you know that this is 8, you could have called this X. This also would have been X. How is that going to help someone? What can they do with that? X squared plus X squared is 8 squared. They could use the Pythagorean theorem. Someone else could have, it's a square, this is a right angle. Could someone use SOHCAHTOA or law of sines to find X?
Yes.
I think that's what Cameron was doing. Perfect. So someone could use trig to find this missing side. So we have 3 different methods to find that side. Whichever method that you choose, that missing side ends up being radical 32, or 4 radical 2 if you simplify. And that's if you used that method. I didn't use those yellow triangles at all. So we're going to go through the other way second. So this person gets the side of the square is 4 radical 2. So to get the area of the square, 4 radical 2 times 4 radical 2 magically gives you 32 as an area. So if you saw that method, awesome. The other people might have said, well, this is 4, and instead of maybe extending just that diagonal, maybe they drew them all in. And so now we have 4 all over the place. Geometry, super visual, it's all about what you see. That's a square, and a square is a rhombus. Why does being a rhombus help us? Because in a rhombus, the diagonals are perpendicular. And the diagonals bisect each other because it's a parallelogram. The diagonals are equal because it's a rectangle. So because these diagonals are equal, bisect each other, and they're perpendicular, we have these nice triangles here. And this triangle also is a 45, 45, 90. And I actually like that triangle a little bit better because the sides are the integers. They're in the nice spot. So now I can just say 4, 4, and the hypotenuse has to be 4 radical 2 if you know the pattern. Or if you don't know the pattern, what do? A squared plus B squared equals C squared, and you get the same thing. Do we have to simplify that piece?
No.
You don't, because the question didn't ask for that side, it asked for the area. So let's say someone did Pythagorean theorem and didn't simplify. It's actually a little bit easier for them.
A lot easier.
A lot easier because when you have a radical times itself, it's just a number. So that square has an area of 32.
You do that out the hard way.
There are variations on these methods, but as long as we can get to 32, we're good. The second square case, radius is 4. Some of you were getting the same answer because you were drawing the radius here. That's not the radius of the circle. That goes outside of the circle. The radius of the circle has to go from the center of the circle to a point on the circle. So it could go there. It could have gone over here. It doesn't matter. But this one's easier because when the radius of the circle is 4, the diameter of the circle is 8. The diameter of the circle is the side of the square.
Oh.
So this one, the area is just 64. Not bad?
I knew a bunch
So,
of radiuses.
This is the type of thing that maybe for 2 points the Regents could ask you to do. Maybe with a picture, maybe without. They could say that we have a square inscribed in a circle of radius 4, a square circumscribed about a circle radius 4, and then they ask you to get the area. If we Yep.
Could you use your compass and then make your circle and then make a square?
They could make it, actually, they could make it a 4-point question and ask you to, they could give you a circle, and for 2 points, say construct a square inside of the circle. And then like part B would say, assuming the circle has a radius of 4, what is the area of the square? If they wanted to make you use your compass. All right, we're gonna skip 5 sides and jump to 6 sides. This one's a little bit trickier because we don't have our base times height or length times width formula for the area of a hexagon. We don't actually have the formula for the area of a hexagon. So we need to find a method that actually is going to work for every shape. And I did this one second, up here. The method that I did for the square, second, involved taking the square and breaking it into what? Triangles. How many? 4. Could I have gotten the area of each of those triangles? Did anyone do it that way? This triangle has an area of 8, and there are 4 of them. 8 times 4 gives you an area of 32. We're going to apply that method over here to hexagon. So I'm going to break my hexagon up into triangles. If a square is 4 triangles, a hexagon, 6 triangles. So we're going to connect the corner of the hexagon to the center of the square. So we might not have the formula for the area of a hexagon, but we definitely have the formula for the area of a triangle. And we actually have 2 options for area of a triangle. You have 1/2 base times height, or what else? What's the other triangle area formula? No, the trig one from the trig chapter. It looks similar to this, but we got to add some trig to it.
No, thank you.
Oh, sine.
1/2 AB sine C. So those are our 2 options. This one, to use this one, what do we have to have? A right angle in there somewhere. The bottom one we don't have to. So all of these questions, same radius of 4. So this is 4. This is 4. My goal is going to be to get the area of this guy. What else do I know in that triangle besides the fact that it has 2 sides of 4?
Oh, actually.
That every angle on the inside, like the interior, is 60 degrees.
The angles at what letter?
H.
H. The angles at H are 60. How are you getting that?
Because the 360 degrees and it's divided by 6.
Yeah, I bet she's going to tell me that that radius is not 4.
Yeah.
Yeah, that's this one. Does 4 belong there?
No.
That is the triangle we want for sure, but that's not where the 4 goes. That's the easy version, and that's going to be problem number 2. Nothing changes. Charlotte's still right. We still have the 60-degree angle. So Charlotte said we have 360 degrees in a circle right here, divided by 6 angles right there. Each one is 60. My goal, still to get the area of that yellow triangle. But my issue is I drew the radius exactly where I told you not to before.
That makes it so much easier though.
It is much easier, and you'd think I would have put the easy question first. I think that's kind of why I was going for that. The easy question is second. This is the hard one. So that 4 actually belongs here.
Oh, that's 1.
Now I will tell you that anytime we put a regular polygon around a circle, the relationship between the side of the polygon and the radius of the circle, they have to make right angles. That has to. We could prove it if we wanted to, why it has to be a right angle, but that will always be a right angle. So Charlotte gave me this 60 That's this angle here is 60. The 4 is this piece right here. How can I get the area of that shape? And again, we do have options. What else do we know in this picture? What do you think?
It's a 30, 60, 90 right triangle. One.
Which triangle?
Well, E.G. H.
Is this H in the center?
Yeah.
EGH is a 30, 60, 90. Nice. So if that's 90, where are you getting 30?
Because 90 plus 60 is
Where'd you get 60?
from 90 plus 30.
Where'd you get 30?
From the angles that's bisecting.
Yes. So this is 30 and 30. There you
Try
go.
to explain it.
Okay. So there's your 30, 60, 90. Can we find sides in a 30, 60, 90?
Yeah.
Yeah. So one approach to this question could be to focus on this green triangle.
Oh, that's
If I redraw that green triangle in pink, I guess, we know the side across from which angle? The 60. Do we, using 30, 60, 90 stuff, have the ability to find this? If you remember the A radical 3 pattern, or A radical 3 2A, sorry. So one person might remember the A radical 3 2A and use it to find this piece here, because they know that this is 4. Another person, if they don't remember that, how else could we get X? Law of sines could get us X. Could SOHCAHTOA get us X? Yeah, so we have law of sines, we have SOHCAHTOA, we have options. Someone could get crazy. If this is X, how big is this piece?
2x.
It is 2X. So could we make the Pythagorean theorem work?
Oh.
Yeah, we have options on how to get that side. But once we get X, can we get the area of that green triangle?
Yeah.
If I have the green triangle, can I get the yellow triangle?
Yeah.
If I have the yellow triangle, can I get the full hexagon? Yeah. Do I really need the green one?
No, because EG is well, that X is going to be 1/2 of the side of the ED,
Mm-hmm.
which means that when you double EG, and then you can multiply it by 6 to get the area of the...
Yes. So he's saying when
Because
you
it's an
find...
equilateral triangle.
Perfect. When you find this length, double it to get this length, and then you can do 1/2 base times height, and go right to that triangle, multiply by 6. Or someone else could just get the, could just get the area of the green. How many of those green triangles are there in the hexagon? 12. So could you take the area of the green times 12? Yes. Messy. Not so fun. And I'm actually not going to show all the steps for this, only because some of you are going to use law of sines, some are going to use SOHCAHTOA, some are going to use Pythagorean theorem. Depends on what you're comfortable with. I will post the full answer to this so you can check to make sure you get the correct area. We're going to go through the octagon one fully, because we all kind of have to take the same approach.
Wait, is it like not a nice one?
It's not going to be pretty. Yeah, you'll have to round it. So go ahead and round it to the nearest 10th. Yep. Yeah, most of the rest of these you're going to have to round to the nearest 10th. Alright, the second one, which is much easier. Same circle, still has a radius of 4. But this time, the radius is where I want it to be. Here's my 4. This makes life a lot easier, actually, for 2 reasons. If that's 4 and that's 4, we know this angle is 60. Aren't I ready to get the area already?
Yeah.
If you know the trig area formula, you have 1/2 times 4 times 4 times sine of 60. That takes you directly to the area of that triangle. And how many of those triangles make up this shape? How many pink triangles make this hexagon?
6.
6. So if I take 6 times that number, doesn't that take me directly to the hexagon? Yeah. Type it in your calculator, see what you get. So 41.6?
Yeah.
Okay. Let's say someone did not know 1/2 AB sine C. If you forgot that, you would have had to draw in the right triangle and use SOHCAHTOA or special right triangles, or use something to get the base and the height of that triangle. And I'm saying that because that's going to be a rule that's going to work whether you have 4 sides, 5 sides, 6 sides, whether it's special, whether it's not special. Yep.
Or you could just see that it's an isosceles triangle
Yep.
and find out that the base angles are the same, and that'll be 60, 60, 60.
So it's equilateral. Yep. So this guy has to be the 30, 60, 90. So if the hypotenuse is 4, the short leg has to be, who knows their 30, 60, 90 patterns? 2, which makes the long leg 2 radical 3. If you know your 30, 60, 90 stuff. So we have options on how to get there. Okay, the octagon. Should we do the easy one first or the hard one first? Easy. Hard? Alright, I'm with you. Let's do the hard one
I
first.
appreciate things so much when they were
That's
easy.
right. Let's do the hard one first. So the hard one is the first one. We're going to get it done with. Same method. All of these questions can be done the same way. Instead of saying, hey, this is an octagon, I have to get the area. What is an octagon made of? 8 triangles. So we're going to work with 8 triangles. So I'm going to focus on this green triangle. The radius of the circle is 4, which is unfortunately not a side of the triangle. The 4 belongs here. What else do we know in this picture? We know that the height of that triangle is 4.
I know the interior angles.
We know the angles. Yeah. How can we get this angle? Divided by what? 8. 360 degrees in a circle divided by, this would have 8 triangles. Tells me that that blue angle is 45. Which means that each half of it is 22.5. Alright, so we need to get an area. To get an area, we always need at least 2 sides. We have options here. Some of you might choose, we have the height of this triangle. Could we use SOHCAHTOA / law of sines to get this length in red? What do you think? Yeah, this is a right triangle. What color do I have left? Orange. If we focus on this right triangle, can I get x? Sure, you could get x using law of sines or SOHCAHTOA. If you have x, can you then get the red piece? And if you have the red piece, can you use 1/2 base times height to get the area of the triangle? Yeah. If you remember the formula 1/2 AB sine C, we could find y instead. So it doesn't matter whether you find x or y, find one of them. And then use that piece with either 1/2 base times height or 1/2 AB sine C to get the area of the green triangle. And then we have 8 green triangles. So take a minute and try and get the area of your full octagon. $67.5? That's my other angle. Yeah?
Yeah.
So we have something that looks like that for X. That's fun. This is not the method I used in the last class. We found Y. So there's X.
Yes.
Very pretty. So to get the area, we have two of those. So if X is 4 sine 22.5, what is the length of this whole thing? Instead of 4, it changes to 8? Or did we think of this as 16 orange triangles? Who did 16 orange triangles? Who did 8 green triangles? Were you just doubling decimals on your calculator, probably?
No,
Alright. So if we aren't just writing, you can write the decimal if you want. You want to use a decimal, go for it. If we use the 1/2 base, it's going to be 8 sine 22.5 over sine 67.5 times a height of 4. So I changed this 4 to an 8 because I needed the red segment, not just the orange one. Does that make sense? If you're just stealing inputs from your calculator, that's fine. Just make sure you show work. And then how many of those do I have? I have 8 of that triangle. And it gives you like 53.01. I think you typed something in wrong. So it's the nearest 10 that we have. 53? Yes? Alright. Now the easy one. Okay, easy one. Same thing. 8 triangles, but it's much easier because our radius is in a much nicer spot. There's my 4. There's my 4. How big is this angle? 360 divided by 8 gives me 45. And it's much easier because I can just say 1/2 A, B, sine of C. And I have how many of those triangles? A bunch, more specific. 8. Type that into the calculator, see what you get for a decimal to the nearest 10. So what these two areas represent, this one is an area that's slightly smaller than the circle because it's inside of it. This one is an area that's slightly bigger than the circle. So where should the area of the circle fall relative to those two numbers? Between it. And I know that these questions seem crazy. You do have 2 of these on your homework with different side lengths. But the only thing that changes, the process is always the same. For these 2 questions, the steps are the same. The piece that's going to change is the first step where you calculated that angle at the center of the circle. So if it has 9 sides, it would be 360 divided by 9. If it has 5 sides, it would be 360 divided by 5. That's going to change. And then moving forward, the numbers that impacts, those numbers would change depending on the angle. And then the radius is just going to change. But that's it. And you do have one of these questions on your quiz on Wednesday.